Okay. Hello everyone. How's it going? I hope you're doing well. In this video, I would like to representing the research study that we have been met before. My name is Pavilion Susanto, and when developing this research study, I'm not alone. I'm in collaboration with my fellow friends that are William Gunawan and also Novel IFC Fawaz Shafiq Abdul Said from Venus University. We are embarked on research endeavor titled Deep Learning for Detection System of Measurement Sleep Quality based on EEG signal. We are also guided by the expertise and mentorship of our lecturers that are Mrs. Judike V. Moniaga and Mr. Said Achmat. This study is aimed to implement the use of long short-term memory model or LSTM model of deep learning to gain the accuracy point test and measuring the condition of the sleep quality using the EEG signal as the input. Okay, for the presentation outline today, we would like to tell you our introduction, like what we want to discuss and what is the main problem of this study. After that, we have literature review that we using the previous study or earlier study as our base foundation to developing this study. And then our methodology, which was the experiment and the method we would like to use to get the results, and the result that are discussion result that we have been experimented before, and our final conclusion about this research paper. First one, the introduction. In order to measure the increasingly frequent and precise reflection of brain activity, sleep researchers employed the electroencephalogram, or we can call it EEG signal, that was a sophisticated biological signal that may swiftly and precisely reflect the physiological changes in the human body. We already know that digital medicine has replaced the traditional healthcare, and health is now our primary study focus to the rapid growth of technologies such as like big data, cloud computing, artificial intelligence, and the Internet of Things. We also already know that many equipment or tools in the medical or hospital environment now has been using the growth of technology such as machine learning, the artificial intelligence to gain the more efficiency and the best results and the training method of diagnose the disease. The next one, the literature review. We are learning from the previous research. This paper research approach and examine over some of the literature from the earlier previous studies, such as CM at number 9, that was focus and look at the study that detect sleep quality using an EEG signal as the input. They are used the four rhythm waves of sleep quality the sleep EEG and as the foundation of sleep staging, because each different sleep stage has its different characteristic waveforms. The reason why we're using the implementation of LSTM model, because this method can achieve a high accuracy point for sleep quality after the WPD processing the signals, and that the MSE will calculate the characteristic and the LSTM model application, and also providing data support for medical institution, because using of the EEG signals, it will cause noise and different individual reference also approach for sleep staging employs AASM standard, which might not be appropriate for all kinds of sleep problems or particular demographics. Okay, the next one is our research methodology. There are four main steps. The first one, we are looking for searching the dataset of complete EEG signal. And then number two, we are looking for the most widely used technique from earlier studies that which is I have been explained before, that are using the EEG signal as the best detection to evaluate the quality of sleep. And then we also need to determine which one of the two models is better for this research, which was the LSTM or long short-term memory model, or the BLSTM, that was the bidirectional long short-term memory. And then we decide to employ the LSTM model to as the AI processing based on the previous research, with notable degree for output accuracy and less challenging in the implementation. And then the dataset we have gained before, we need to reprocessing first the EEG signal using the decomposition of wavelet pocket, or we can say the WPD. The detection process will determine automatically staging preprocessed and collected original sleep complete EEG to extract the 4 rhythm waves of EEG signal using the wavelet pocket decomposition. Each rhythm waves relative energy and nonlinear characters are retrieved, and so the multi-scale entropy or MSE number of multiple scales of computed the key characteristic, with the remaining characteristic becoming auxiliary. And then after we do the decomposition, we will train the noise signal using the LSTM model. After the dimensional reduction, they are sent to the LSTM model to return the final result. The main concept of LSTM model is swap up each the RNN's Haydn's unit for a memory functioning well, leaving the other structure to change as the current anticipated position grows, and for acquiring the remote information will be diminished. And after that, the result of the test will be calculated and we gain the accuracy of the trained model. And then this is the results we experiment before. Based on the experiment we conducted above, that this paper deep learning obtained only 14% accuracy based on the examination average, as attested to by the technique, and the greatest accuracy we reached only 70%. We have already verified and ran many tests to improve the value of the test accuracy. Thus the model is decreasing the loss of value and raise the accuracy, but our team was unable to improve the results. We hypothesized that in order to handle the manage all the datasets into classification and processing into the LSTM model, we will still to make errors when managing the data, even though the model we developed was correct, since it can display the result of the training models. However, our team thought that is less excellent and accurate in handling the EEG signal dataset. Therefore, further study is needed to increase the accuracy outcome so that the AI can represent the final findings more precisely. And this is what is our conclusion. From the experiment on this paper, our teams have found a conclusion that using the LSTM model to train the signal, the EEG signal, it should be effective in calculate the final accuracy test. But because the mistaken we did, we couldn't gain the height of accuracy of this training model. The result of the study demonstrate the feasibility using of LSTM architecture for EEG data processing and highlight their capacity to determine sleep quality by capturing the temporal relationship present in brainwave pattern. The finding revealed that the integration of WPD significantly improved the accuracy of LSTM by eliminating the external signal, thus enhancing its ability to discern relevant patterns in EEG data. I think that's it for my presentation about this research paper. I apologize for the mistaken and disadvantage from this paper, and I see you guys later.